Hello everyone, my name is Rinku Taide and today's lecture on database design and I will explore some important concepts such as normalization, functional dependency, decomposition, multi-value dependency and query optimization. So let's get started. The first topic is database design. Database design is the process of structuring a database so that the data can be stored, retrieved, and maintained efficiently. A good database design ensures correct arrangement of data, eliminates redundancy, and supports fast transactions, and becomes the foundation for normalization and query optimization. The question is why database design is needed. A proper database design is essential for system performance. If design is poor, the system becomes slow and inconsistent and difficult to maintain. That's why before implementation, we always start with designing the structure. Next topic, introduction to normalization. Normalization is the technique that helps us to organize data in such a way that redundancy is minimized. It breaks large tables into smaller and meaningfully tables using functional dependencies. It also helps avoid anomalies during insert, update, or delete operations. Why do we need normalize? We normalize a database to avoid problems like data repetitions, inconsistencies, and storage wastage. Normalization ensures data dependency is logical and improves overall structure and maintainability of the database. Here is the types of normal forms for 1NF, 2NF, 3NF. Normalization is performed step by step from 1NF to BCNF and even 4NF and 5NF in advanced cases. Each normal form removes a specific type of issue in the table structure. Next is functional dependency. Functional dependency is the backbone of normalization. It states that if attribute X uniquely determines attribute Y, then Y is functionally dependent on X. For example, student name is dependent on the roll number. Importance of functional dependency. Functional dependency help us to identify keys for a relation and are used to normalize tables. Normalization from 1NF to BCNF is heavily relies on the correct identification of functional dependencies. Types of functional dependencies. Let's understand different types of functional dependencies. Tribal tribal FD, non-tribal FD, full functional FD, partial functional and FD, and transitive FD. So first is a trivial functional dependency when the right hand attribute is already part of the left side, and the second is when the right hand attribute is not part of the determinant. And in full functional dependency, a non-key attributes depend on the entire composite key. Next is partial dependency. A non-key attribute depends on part of a composite key. This violates 2NF. And transitive dependency, if A subset to B and B subset to C, then A indirectly subset to C. This violates 3NF. Multi-value dependency, one attribute determines multiple independent values of another. Uses of functional dependencies in normalization. Functional dependency is essential because it tells us how attributes relate to each other. It helps eliminate redundancy and anomalies by decomposing tables into smaller and well-structured relations. Now let's see decomposition. Decomposition means splitting a large relation into a smaller relation. Main goal removing redundancy, reducing anomalies, achieving lossless join, and preserving functional dependencies. For example, splitting a student table in a roll number, name, course, department, and HOD into two tables reduces redundancy. The advantage and disadvantage of decomposition is decomposition improves performance and remove anomalies, but excessive decomposition may increase joint cost. Also, it depends if dependencies are not preserved, constraints may become difficult to enforce. Next is dependency preservation. A decomposition is dependency preserving if all functional dependencies can still be enforced on the decomposed tables without joining them. This ensures efficiencies and consistencies. Now see, lossless join. A decomposition is loss join if after splitting tables we can reconstruct the original relation exactly. Common attribute between decomposed table must be a key to ensure lossless join. Problems with null value tuples. Null values create because we cannot determine if the data is missing, unknown, or not applicable. It affects comparison, aggregation, and even join operations. Problems with dangling tuples. Dangling tuples occur when a tuple in the child table references a missing tuple in the parent table. This violates referential integrity and may result in incomplete joint results or operands recalls. Multi-value dependency. Multi-value dependency occurs when one attribute determines multiple independent values of another. It leads to redundancy and anomalies. For example, a student is having attribute values like hobby, student language, like that. Why MVD causes problems? MVD causes insertion, deletion, and update anomalies because multiple combinations are stored. Hence, we break the table using 4NF to remove MVD based redundancy. And MVD and 4NF. 4NF states that if A is subset to B and A must be a super key to remove MVD, we split the tables such as splitting student hobby language into two separate tables. Introduction to query optimization. Query optimization is the process of choosing the most efficient and execution plan for a query. It helps to reduce CPU, memory, disk uses and improves retrieval speed. Steps in query optimization. First is parsing, second is creating query tree, third is applying optimization rules, then generating alternative plans, then estimating cost and executing the best plan. Next is algorithm for select, project and join. For executing queries, dbms uses algorithms. First is select. In select, perform some steps like linear search, binary search, and index or hash based selection. Then next is project, which perform simple projection with duplicate removal. Next is join. Join perform nested loop join, uh, short merge join, hash join. Next is query optimization methods. There are two approaches. First is heuristic based optimization uses rule of thumb techniques, and second is cost based optimization, which evaluates the cost of multiple plans and selects the best one. Heuristic based optimization, here selections and projections are pushed down early, and joins are recorded and Cartesian products are avoided. It is simple and fast, but may not always give the best plan. Cost based optimization. This approach considers strict important input and output cost and memory uses to choose the optimal plan. It is powerful but computationally heavy. Now, thank you.